On this problem, we're to sketch the graph of a rational function. It asks for a bunch of extra questions. Asks the bit domain, any holes, horizontal, vertical asymptotes, x and y intercepts, etc., etc. The first thing that I do on this question is to factor everything I can so that I can see what this thing is made up of. I have x plus 3 times x plus 1 on the top, and x minus 4, x plus 3 on the bottom. And right away, I can get the domain. I'm going to write the domain in set notation because of the efficiency of it. X cannot equal 4 or negative 3. And the reason for that is because if I use 4, I get a divide by 0. And if I use negative 3, I also get a divide by 0. We can't have any divide by zeros, those are undefined. I next notice that the x plus 3 factor reduces. When a factor reduces, what we get is a whole. The whole is at negative 3. I don't know the y value though. I do know the x value. So although it originally had an x plus 3 in the numerator, making me think that it might be an x-intercept, also I saw it in the denominator, which would suggest a vertical asymptote. The fact that it was both numerator and denominator, it eliminated other than the fact that originally it couldn't equal negative 3. Therefore, this is just a whole. If I plug in to the simplified version the negative 3, I get negative 3 plus 1 on the top, and negative 3 minus 4 on the bottom. I get 2/7. That's how we finish the coordinates of the whole. Horizontal asymptotes. This is about comparing the leading term in the numerator and denominator. If the degrees are the same in the leading terms, 2 and 2, then we look at the coefficients in front of them, 1 over 1, and we get y equals 1 over 1, y equals 1. Vertical asymptotes are based off of what's left after simplifying. We still have a 4 as a problem. That's x equals 4 is the vertical asymptote. X and y intercepts. The y-intercept happens when we plug in 0 for x. And plugging in 0 in for x is probably easiest done at the original. We get 3 over negative 12. Or we could do it here. 1 over negative 4, same result, negative 1/4. Intercepts should be ordered pairs. And then the other intercept is when y equals 0. Now for y to equal 0, the whole fraction has to equal 0, and that happens when the numerator equals 0. So if I use negative 1 for x, we'd get 0 over negative 5, which is 0. So negative 1 leads us to 0. That would be the x-intercept. Lots of information. Let's take a look. Let me graph the asymptotes first. So this is y equals 1 and x equals 4. Let me label that x equals 4. By labeling something on the x-axis and something on the y-axis, I've labeled the scale. X-intercept, 0, negative 1/4. That was the y-intercept. The x-intercept, negative 1, 0. And the whole is at negative 3 and 2/7, approximately right there. I have enough information on this side to see what this part of the rational function is doing. That one didn't work too well. Make sure that your rational function is always going towards the asymptote without decreasing or going parallel. Hard for me to graph with this tool. Now there's also something over here. And so I'd want to plot a couple more points. Let's see, that's 4 or 5. Let's go with 5 and maybe 7. Plugging this in, 5 plus 1 is 6. Over 5 minus 4 is 1. 6 5, comma 1, 2, 3, 4, 5, 6. It's right here. And if I plug in 7, I get 7 plus 1 is 8. 7 minus 4 is 3. 8/3, a little less than 3. That gives me an idea of what this side is doing. And there we have everything graphed and answered. And I hope this helps.